Good morning, super science educators. This morning, I am going to be talking to you about taking your students from just a regular old novice learner in science to a science expert. When students are moved from a novice to an expert in science, they will naturally become masters of the standards. I know that we are oftentimes beat over the head about students mastering the standards. Well, what I've learned is when I use the three dimensions of science, it helps me create more meaningful science instruction, therefore, allowing my students to master those standards more easily. So, what I typically start with I always go to the next generation science standards in conjunction to my own state's science standards, which pretty much mesh well with each other because many of the states have rewritten their science standards to look very similar to those of the next generation science standards. And I always start with looking at the disciplinary core ideas. Then I go into the science and engineering practice. Then I look at the cross cutting concept. These three um, things work with each other to help students become science experts. So let's start by having a good understanding of what disciplinary core ideas are. Those are just the content standards. They are drilled down into smaller, more understandable parts. These ideas are used by students to construct scientific explanation and to use as evidence to drive scientific arguments. The core ideas will allow for your students to not just be these regular fact finders, those regurgitators of information, but it will allow students to have a deeper understanding of how and why science phenomena occurs. Students will be allowed to become the experts in their specific core idea areas when they look at these more drilled down areas within that content. And so, for this particular standard, which is state of matter, and when I'm looking at my specific standard, which is S8P1B, develop and use models to describe the movement of particles in solids, liquid, gases, and plasma states when thermal energy is added or removed. I know the domain would be physical science, and the disciplinary core idea would be matter and its interaction because we're talking about those specific states of matter interacting with thermal energy. So the cross-cutting concept, well, no, our science and engineering practice. Basically, what that entails is what the student will be doing. You want a doing student, not a hearing student. You want a doing student. You don't want your student to be sitting and getting. You want them to be doing something hands on so they can apply the information that they've learned. So, those students will be doing something to make sense of the phenomena. They will also be designing solutions to problems that exist in the real world. And we know that our world has a lot of problems. So our students are not only scientists, but they are also engineers. Allow your students to be individuals. I love for my students to be individuals. I recognize that all my students are different. I recognize that they all think differently, and I'm okay with that. There is not a one size fit all model in my classroom because I know that their different thought processes still will allow for them to come up with a very similar solution. or they're going to be innovative, creative in their own rights. So I am very, 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 very much open-minded to my students having their own independent way of thinking about scientific inquiry. So when we're looking at our science and engineering practices, it's all about what will your students do? And in this specific standard, the students will develop and they will use models. And super science educators, let's always keep an open mind that those models could be students using their own bodies to emulate whatever um, core idea they're studying. So it doesn't have to be something that they build from materials. It doesn't have to be something that they draw on paper. It can be them physically using their bodies to act out specific parts of those core ideas. And I will be sharing many, many videos of how my students, they love to act. They're the greatest actors in the world. Students are great actors, and we all know this. So allow your students to not just do with their hands, but use their bodies to act out different core ideas, because that's still allowing them to hit those standards so that they can master those standards. So, what are those cross cutting concepts that we're looking at? The cross cutting concepts are the concepts that apply across all areas of disciplinary core ideas. So, I've had the pleasure of teaching sixth, seventh, and eighth grade in 1 year. And those cross cutting concepts will extend across sixth grade, seventh grade, and eighth grade, and even my high school course. With these cross cutting concepts, there are the tools to help the students understand and organize the phenomena studied from one core idea to another core idea. So your cross-cutting concept, you can have like patterns. There are specific patterns that students will observe from one grade to another grade. This particular standard, the cross-cutting concept, is cause and effect. So what is the cause? The cause is adding thermal energy or removing thermal energy will affect matter. How does it affect matter? It affect matters where it will cause each state of matter to move differently. So this specific cross-cutting concept is cause and effect. I'm going to be sharing the Next Generation Science website, and we're going to go and look at it in more detail to kind of help you successfully maneuver through it so you can help bring your students from just novice learners to experts in science. I always also have an essential question in my lesson. How do particles of each state of matter behave when thermal energy is added or removed from each state of matter? And I like to use the word behave, and I use the word behave because when those students start seeing those models, they start developing those models, they start mimicking those models. There's a certain way that they behave, and that helps them bridge the information to see how the specific states of matter behave. So I like to use the word behave, and I use that word on purpose. I try to be very purposeful when I'm using certain terminologies in my classroom. Then the learning target. The learning target is what you can, what your I can, what you're able to do as a student as we go through this lesson. So my learning target for my students, I can describe how the particles in solids, liquids, gases, and plasma states move when thermal energy is added or removed. So as I go throughout this particular standard, I'm going to be sharing with you, many lesson ideas, activities that I love to do with my students, that help them to become science experts as it relates to matter and interaction in this particular standard. So please stay tuned for the next video where we will be going through the next generation science website and becoming more effective users of this particular site so that we can bring our students from novice learners to science experts, showing that they can master those standards. If you have any questions for me, if you have any comments for me, please drop those below or send me an inbox. And again, thank you for checking in with the Super Scientist at the Kids Corridor Super Science Fun. And I look forward to getting to know each and every one of you. And I look forward to us moving in a positive direction together as super science educators.